Hello, students. Today we'll explore two exciting topics, friction and its application in circular motion of a car. These concepts are crucial for understanding how objects move and interact with their surroundings. So let's get started. Friction. Friction is the force that resists motion when the surface of one object comes in contact with the surface of another. There are basically four types of friction: static friction, kinetic friction, rolling friction, fluid friction. Static friction. Imagine a body with mass m resting on a horizontal table. It experiences two forces, gravity pulling it down, mg, and the normal reaction force from the table, n. But what keeps it from moving? It's static friction. Static friction, denoted as Fs, opposes impending motion. It only arises when an external horizontal force F is applied. As F increases, static friction increases until it reaches a maximum value. Equation for static friction Fs max equals to mu s n. The maximum static friction Fs max depends on the coefficient of static friction mu s, which varies with the surfaces in contact. It keeps the body at rest. Kinetic friction. But what happens when F exceeds Fs max? The body starts moving and static friction transitions into kinetic friction, Fke. Kinetic friction continues to oppose motion between surfaces but is nearly independent of velocity and contact area. It's governed by mu k, the coefficient of kinetic friction, typically less than mu es. Equation for kinetic friction Fk equal to mu ek, n. When F is removed, the body decelerates due to kinetic friction until it comes to a stop. Friction plays a vital role in our daily lives. It's why we can walk without slipping, and cars can accelerate and stop. In machines, friction can be both helpful and problematic. Lubricants and ball bearings reduce kinetic friction, while maintaining a thin cushion of air minimizes it. Rolling friction. Rolling friction is another type of friction that occurs when a wheel or a ball rolls without slipping on a surface. It's much smaller than static or kinetic friction and is crucial for the operation of wheels. Fluid friction. Fluid friction is friction that acts on objects that are moving through a fluid. A fluid is a substance that can flow and take the shape of its container. Fluids include liquids and gases. Circular motion. In a circular motion, the force directed towards the center is called the centripetal force. Centripetal force of a body of mass m moving in a circle of radius r with uniform speed v is Fc equals to mv squared by r. For a stone rotated in a circle by a string, the centripetal force is provided by the tension in the string. The centripetal force for motion of a planet around the sun is the gravitational force on the planet due to the sun. For a car taking a circular turn on a horizontal road, the centripetal force is the force of friction. The circular motion of a car on a flat and banked road gives interesting application of the laws of motion. Motion of a car on a level road. In the motion of a car on a level road, there are three forces act on the car. 1. The weight of the car mg. 2. Normal reaction n. 3. Frictional force F. As there is no acceleration in the vertical direction, n minus mg equals to 0, implies that n equals 2 mg. The centripetal force required for circular motion is along the surface of the road, and is provided by the component of the contact force between road and the car tires along the surface. The static friction provides the centripetal force. Therefore, Fc equals to mv squared by r less than equals to mu an, implies that mv squared by r less than equals to mu mg, because mg equals to n, implies that v squared by r less than equals to mu g, implies that v less than equals 2 root over mu gr, which is independent of the mass of the car. This shows that for a given value of mu and r, there is a maximum speed of circular motion of the car possible, namely Vr max, equals 2 root over mu gr. Motion of a car on a banked road. We can reduce the contribution of friction to the circular motion of the car if the road is banked. Since there is no acceleration along the vertical direction, the net force along this direction must be 0. Hence, n cos theta equals to mg plus f sine theta. The centripetal force is provided by the horizontal components of n and f. Therefore, n sine theta plus F cos theta equals to mv squared by r. To obtain maximum velocity, let us put F equals 2 mu n in the equation 1 and 2. The equation 1 gives n cos theta equals to mg plus mu n sine theta. And the equation 2 gives n sine theta plus mu n cos theta equals to m v squared by r. Simple solution of the equations 1 and 2 gives v max equals 2 root over rg multiplied by the ratio of mu plus tan theta and 1 minus mu tan theta. 4 mu equals to 0. v0 equals 2 root over rg tan theta. Therefore, at this speed, frictional force is not needed at all to provide the necessary centripetal force. Driving at this speed on a banked road will cause little wear and tear of the tires. I hope you've gained the basic understanding of friction and its application in circular motion of a car. Keep exploring the world of physics and you'll discover even more wonders. Stay curious and happy learning, and I'll see you in the next video.